This is 9.7a of algebra. So we've looked at linear, quadratic, and exponential functions, and now we're going to look at all of them together. Okay, so here's a nice little review for us of what the graphs look like, what the equations are, and what the names are. Okay, so linear is a straight line, quadratic is a parabola, or a U, and exponential starts getting bigger slowly and then starts getting bigger and bigger and bigger quicker. So, we're going to figure out which one is the best model by graphing it. So we're going to start by looking at these points here. And I'm going to make myself a graph. And we're going to graph them. If you are not comfortable with graphing points, that's something we need to work on, okay? So 0, 0, 1, 1, -1, -1/2, and 2, 3. So I'm going to connect these. And maybe it becomes clear when I connect them. This one is going to be an exponential, okay? It's clearly not a parabola. It's not making a U. And I can tell that it's not a straight line because, let me switch colors here. I cover half a unit here, a whole unit here, 2 units here, okay? When we're working with linear, it'll go up by the same amount. So this is exponential. Let's try the other one. So, -2 goes to 11. So that's going to be like up here. I realize it's off my graph, but -1 goes to 5. 0 goes to 3, and 1 goes to 5. So we've got a U here, or a parabola, so this is a quadratic. Okay, here's where it gets a little trickier. We were looking at points and graphs. Now we're going to look at tables. Let's look at this first one here. This is linear, okay? In all of them, when you're looking at your x's, you want your x to go up by the same amount each time. So they all go up by 1, or they all go up by 2, okay? So on the left, for all the x's, it's always going to be added. Okay, you're adding the same amount there. Where it changes is the y's. So if we look at linear, we are adding by the same amount each time. Okay? If we look at exponential, we are multiplying by the same amount each time. And now if we look at quadratic, this is the one where it looks a little crazy, okay? You find your first difference, like how much you're adding or subtracting by each time. And you can tell those are not all the same. Here's where the crazy part happens. If you look at the difference of all of those numbers, so how to get from -2 to 2, how to get from 2 to 6, how to get from 6 to 10, okay? That's these numbers over here, and they're all the same, okay? So if you're doing quadratic, you've got to do it twice. So let's try a table. So we're given points, and I'm going to stick that into a table, okay? So x and y. -1 and 0.5, 0 and 1, 1 and 2, 2 and 4, 3 and 8. So I'm going to check for adding and I'm going to check for multiplying, okay? So to get from 0.5 to 1, I would add 0.5 or I would multiply by 2. To get from 1 to 2, I would add 1, or I would multiply by 2. Just because I have 2 multiplyings there that match up, I'm not going to stop because it could change going on, and I could be looking at a quadratic, even though, because the addings wouldn't be the same yet, right? So I'm just going to be thorough and do both all the way down. To get from 2 to 4, I would add 2. I could otherwise multiply by 2. To get from 4 to 8, I could add 4 or multiply by 2. Now that I see that all of these have multiplying by 2, I know that's my difference, okay? Don't guess right away. It's possible that 2 have the same multiplying, but wouldn't have it later on. So, this is exponential, because you're multiplying. And there's your homework.